The impact of negative species interactions, whether that's competition or our various plus minus interactions, somewhat depends on the system that you're looking at. And so these are whether the system is what's called a bottom-up model of control or a top-down model of control. In the bottom-up model of control, food limitations controls population density. So this is a competition. So this is a competition, an emphasis on competition, I should say. And so the idea is that plants and how many plants there are regulates how big the populations of herbivores and carnivores can get, because the herbivores and carnivores are depending on the plant size and plant population for food. So it's really saying that nitrogen and the nutrients that feed plants are also limiting. So if you added more nitrogen, for example, you would get more plants, and that would therefore cause more herbivores and more carnivores. So another way to understand this is to think about what this model, the bottom-up model, predicts about population growth. So for example, if you have a decrease in plant populations, so a decreasing plant population, the bottom-up model of control predicts that the grasshopper population would also decrease and that the carnivore population would also decrease. So starting here, it causes a decrease all the way up the food chain, as it were. And then in the same vein, if you have an increase in the plant population, your grasshopper population can also increase, and your carnivore population can also increase. So plant increase, herbivore increase, carnivore increase, again, starting from the bottom. And that would be in the bottom-up model of control. The top-down model says, no, it's not the plant size that matters, it's the natural enemies that matter. So the predators or the herbivores that control population densities. So it says the predators keep the herbivore population low, and the herbivore population controls the plant population. So in the top-down model, we think about this in a little bit different way. We start at the top and move down in our predictions. So if I have a decrease in my predator population, then that will cause an increase in my predator population, right? So less predators means I can have more herbivores. And if I have more herbivores, then that means there's going to be a decrease in my plant population because now they're eating the plants more. So the order of effects is first at the top, there's an impact that has the opposite effect on the next level, and then the opposite effect on the next level. So a decrease in predators causes an increase in herbivores, which causes a decrease in plants. Okay, so if I consider the opposite, an increase in predators, okay, an increase in predators will cause a decrease in the herbivore, and the decrease in the herbivore will cause an increase in plants. So again, I'm starting at the top and working down to understand the impacts. So let me put out one other question. In the top-down model, if I have an increase in plants, what effect would that have? Okay, in the top-down model, there's no effect of that. Because again, the plants aren't controlling anything. They aren't controlling the population. So in real world, right, in real life, no system is always one or the other, right? Population control is dynamic. That is, sometimes an ecosystem might be experiencing top-down control, and sometimes it might experience bottom-up control. And this will oftentimes depend on the availability of plant resources. So if there's not that many plant resources in an ecosystem, then bottom-up control may occur. So this would make the effect of competition for food much stronger. However, if there's an abundance of plant resources, like if there's more plants available than are needed, then the predators are more likely to exert more control, making it a top-down system. So again, an ecosystem may experience different mechanisms of control, based on variable things that might be happening, like a drought. A drought might cause there to be bottom-up control when normally there's top-down control. Okay, so it's not always a fixed state for an ecosystem.